This is the solution for the Wormholes problem on the December 2013 USACO Bronze Contest. Let's go ahead and just dive into the code, and as we go we'll talk about how we actually generate and test all of these different solutions. This is a problem basically that's intended to test your knowledge of recursion, because recursion is the best way to generate all possible ways to pair up the wormholes. So let's see, I'll go ahead and include IOStream and include fstream using namespace std, so standard header stuff. And then let's go ahead and read in the input. So what I'm going to do with this problem, I'm going to have an array of x values, an array of y values. I'm actually, and I think there's at most 12 of them, I'm actually going to use 1-based indexing. So the array is going to go from 1 up to n as opposed to from 0 to n minus 1, because I'm going to use 0 to indicate special things like a wormhole not being paired or someone not existing on the right of a wormhole. I could use maybe -1 as well, but I'll just make everything 1-based. And I'll also, I guess, need a global variable for n, the number of wormholes. So let's create an input file stream, fn wormhole.in. fn reads in n for I equals, I guess, 1 up to n, I++, and I'm going to read in x of I and y of I. And then fn.close. Okay, we've read the input. Let's go ahead and write the output. So ofstream fout wormhole.out, and I'm going to just output well, what I get when I solve the problem, followed by a new line. Then close the output file, return 0, and we're good to go. We have read the input and written the output. All I need to do is solve the problem. So I need to write this solve function, which is going to be responsible for counting all the possible solutions that I can get by pairing up the wormholes and counting all the configurations where I end up with a cycle. Okay, so to do that, I'm actually going to enumerate, using recursion, all possible ways of pairing up the wormholes. And to do that, I actually need to keep track of which wormhole is paired with which other wormhole. So let's make an array, maybe call it partner. Max n plus 1. So partner of I is going to be the index of the wormhole that's paired with I. And so what I'm going to do is, for example, I could say something like, in my solve function, I'm going to find the first unpaired wormhole. That's not too bad. So, int I for I equals, I keep forgetting it's 1 base, so I equals 1 up to n, I++. And then I can say if partner of I is 0, then I can break out of my for loop. So this is going to stop the for loop when I hit the very first unpaired wormhole. Then what I'm going to do is I'm going to try pairing that wormhole with everyone else after him. So I'm going to try pairing I with all possible other wormholes, j. So for int j equals, I guess the first one available would be I plus 1, j less than or equal to n, j plus plus. If the partner of j is also 0, that means j is also unpaired. Then I'm going to try pairing I and j. And I'm going to let recursion continue to generate the rest of the solution. And so the way that works is I'm going to say, partner of I is j, partner of j is I, and then I'm just going to say solve again. And solve is then recursively going to go and again find an unpaired I and match that person with an unpaired j, and then again recurse, and so on. Eventually it's going to complete the matching, and we're going to need to put in some sort of a base case for when everybody's matched, but we'll do that in a second. So after we try we recursively complete the solution where I and j are paired, then I'm going to put them back to the way we found them. Partner of I equals partner of j equals 0. This is a very standard thing that you do with recursion. You try setting some small part of the solution, you recursively call yourself to finish off the solution where I and j are paired. So, we set I and j to be paired. Calling solve will then recursively generate every possible solution where I and j are paired, and then we unset the pairing between I and j and then back up. So basically, set a particular part of the solution, recursively complete the solutions with that particular setting, and then undo the setting that we did. So that'll allow us to back up properly. All right, so what do I need to do during this process? Well, solve is going to count all the solutions that it encounters. So as I call solve here, I actually need to tally up all the solutions that solve is reporting to me. So I'm going to have to say like total plus equals solve. And I guess I need a variable total. So this is going to keep track of all the answers that I'm counting up during this process. And at the very end, I guess I'm going to return that total. So all I need to do now with my solve function is handle the base case where I've actually paired everybody up. And so let's see, I can probably put that here. So everyone paired. And I can test that. So here I find the first unpaired wormhole. If this for loop goes all the way past n, then everyone is paired. So if I ends up being bigger than n, then everyone's paired. And if everyone's paired, and this is the case where I don't further recurse, I'm going to test the solution, because now the partner array has a pairing for everybody, and all I need to do is test if there's a cycle formed by the wormholes. So if, say, a cycle exists, I'll have to write that function, then I'm going to return 1, because this is a valid cycling solution. Otherwise, I'm going to return 0. So this is my base case because it does not further recurse, it just exits, returning either yes, this was a valid solution that cycles, or no, it's not. So this is the structure of my recursive enumeration. So I'm just basically enumerating every possible solution recursively, and for every solution that finally is completed, I'm going to test it, whether or not there's a cycle. So ultimately I'm going to need a cycle exists function. It returns true or false. So cycle exists, and that actually doesn't take any parameters because it can just look in the partner array and figure out if there's a cycle or not. Now what if I were to just return true here? This is possibly a good place to stop and test our code. If I return true here, that means that every possible pairing of the wormholes is going to count as a valid solution. And so if you look at, say, wormhole.in, there are 4 wormholes. There were, 3 ways to pair them up, I think, in total. So I could pair them up, if I number them 1, 2, 3, 4, one possible pairing is 1 paired with 2, 3 paired with 4. I could also do 1 paired with 3 and 2 with 4, and I could do 1 paired with 4 and 2 with 3. So there are actually 3 ways to pair the wormholes. So this should actually output 3. It should count everything as a valid pairing, because it's not even doing the cycle test. But it's probably a good place to stop and actually, as a sanity check, make sure that we get the output that we're expecting to get. So let me go ahead and compile and run at this point. So let me see. If I do a G++, I'll call my executable wormhole.cpp. No compiler errors, that's good. I'll run wormhole, and then I'll output wormhole.out, and I do get 3. Okay, so that's a very good sanity check that it is, we have some confidence that it's actually enumerating through all the different solutions, all the different pairings. In fact, I could even print them all out. That might even be an even better sanity check. For int I equals 1, I less than or equal to n I++. And this is always a good idea with any kind of programming, not just contest programming. Don't just write your entire program and run it hoping that it works, but write pieces of your program and test them as you go. Therefore, when you find a bug, there's less code that you have to look at to figure out where the bug comes from. So I'm going to just output maybe is I : partner of I, and then a space, and then I'll finally output a new line. So this is just going to print out all the different pairings that I get. So if I run wormhole, we can actually see that 1 was paired with 2, 2 was paired with 1, 3 with 4, and 4 with 3. So that's the first pairing. Then 1 with 3, 3 with 1, 2 with 4, 4 with 2, and then 1 with 4. So this does in fact tell us exactly the 3 pairings that we expected to see. So we now have some confidence that we are enumerating things correctly. And so I can get rid of this debugging code. I should probably actually comment it out because you never know when you might need it, but let's assume that our enumeration is correct. All we need to do now is test whether or not there's a cycle of wormholes. Now to do that, what am I going to do to test if there's a cycle? I'm going to basically, if there's a cycle, then that means that starting at some wormhole, if I go to his partner and then go to the right, I enter another wormhole, go to its partner, then go to the right, and so on. If I do that for a certain number of steps, I am going to get stuck in a cycle. If there's no cycle, then after a certain number of steps, I'll find some wormhole that has no further wormhole on his right. Because remember, Bessie moves in the plus x direction, so parallel to the axis. So eventually, if I get to a wormhole that has no other wormhole on its right, in the plus x direction, then I am finished. So what I'm going to do is I'm going to, let's have a loop here over all possible starting locations. So start equals 1 up to n. And I'm going to test if there's a cycle. Let's see. Well, I'm not sure what I'm going to return yet at the end. I'm going to test, does there exist a cycle starting from start? So test all possible starting wormholes and kind of just trace out the cycle starting from each one. And if I ever end up at a wormhole that has no further wormhole on its right, I know that there's no cycle. Otherwise, I'm going to get stuck in a cycle. So I'm going to just take a certain number of steps. So int maybe count equals 0, count less than n steps is probably fine, because if you get stuck in a cycle, you're going to be cycling every less than n steps. If you take put otherwise, if you're at a wormhole that does not lead to a cycle, you will discover this fact after taking no more than n steps, right? Because if you take more than n steps and you're still at a valid wormhole, that means you're stuck in a cycle. So I'm going to take n steps, and what I'm going to do is I'm going to take my current position, which starts out at the starting place, and I'm going to update my position to, well, I'm going to have to take the partner of my current position, and then I want to find so I teleport from my current position to the partner of my position, and then I have to move to the next wormhole on my right. So maybe call that next on right of my partner. And that's all I'm going to do to trace out this cycle. I still need to, I guess, create this array next on right that tells me who is the next wormhole to my right. But basically, from each position, I jump to the partner of that position, who's paired with me, and then I move to the next wormhole on his right. And I keep doing that over and over and over, n steps. If I ever end up finding someone who does not have a wormhole on his right, next on right is going to be 0, I guess, in that case. And position is going to be 0 in that case. I'm going to basically say partner of 0, next on right of 0. That's going to stay at 0 from that point on. So if position ever ends up at 0, that means I did not end in a cycle. That means I ended up kind of falling off the end to the right when someone didn't have a right partner. So in this case, I didn't find a cycle with this particular starting point, but if position is not 0, then I did find a cycle, so I can return true. And that means probably here at the very end I need to return false, because that means I didn't find a cycle from any starting point. So basically just, to find if there's a cycle, try all starting points. For each starting point, just trace the cycle around for a sufficient number of steps, and after n steps, if you're still at a valid location, that means you are in a cycle. Because otherwise you would have reached position equals 0 at some point along the lines. So all I need to do now is initialize this next on right array that just tells me for each wormhole which is the index of the wormhole immediately on its right. Where should I put that? Let's just maybe put that in the main function after I read the input in. So int I equals 1, I less than or equal to n, I plus plus. So what I'm going to do here is I'm going to set next on right of I. So who is the index of the wormhole immediately to the right of I? Initially it's going to be set to 0, assuming there's nobody on my right, and that's fine because whenever you declare an array globally in C or C++, it actually is automatically initialized to all zeros. That's a very convenient thing about using global variables. You can assume they're always initialized to zeros, which we're going to depend on. If instead you create an array inside a function like this, then actually in this case you cannot say anything about how it's initialized. It could be initialized to garbage. So next on right I know starts out at 0. And all I need to do now is reset that value if I find people on my right. So let's loop over everybody else. Int j equals 1, j less than or equal to n, j plus plus. So if j is on my right, I guess that means if x of j is bigger than x of I, and they have the same y value, y of I equals y of j, so j on right of I, then in that case I need to say, is j closer on my right than who my previously found next on right guy was? So if, let's see, if I don't yet have someone on my right, or if j is closer, so if the distance to j, which is this, is less than the distance to the previous guy on my right, so x of whoever was previously on my right, if that distance is less than that, then I want to set next on right of I to j. Okay, I think that is all I need. So I go through and I set everybody's next on right value to point to the wormhole that is next on his right. I recursively enumerate all possible solutions. For each one I check if it creates a cycle, and sure, let's see if it works. So I will go ahead and recompile. Wow, still no compiler errors, doing good. Run wormhole. The correct answer should be 2. So wormhole.out says 2. Awesome. So I think we're good to go here. I'll go ahead and upload the code, and hopefully this was informative as a way of recursively generating solutions. A very standard sort of thing that is usually among the hardest things we do in the bronze level. So mastery of recursion is kind of a good indicator of whether you're ready to progress from bronze to silver. All right, I'll go ahead and upload the code.